Question number 2. The nuclei of some isotopes are radioactive. 2.1 is an A1 question. Which of the following statements could apply to a radioactive nucleus? The student must have a good knowledge about the concept of the isotopes, the radioactive decay, and the nuclear radiation. We need to pick one of the box. The nucleus will emit an atom. The nucleus will emit the light. The nucleus will emit a neutron. The nucleus will emit the sound. Nucleus is part of the atom, therefore the nucleus will not emit an atom. So this is a wrong option. The nucleus is not emitting the light. So this is a wrong option. The nucleus is not emitting the sound. So the last option is also a wrong option. The nucleus will emit a neutron. This is the correct option. Two point two is an year one question, and this question is from the topic of nuclear equation. Potassium 40 is a radioactive isotope present in the food such as bananas. The following equation shows how potassium 40 will decay into calcium 40. The nuclear equation is given here. We need to compare the left and right side of the equation. The atomic number is 19 and the mass number is 40. If you see on the right side, the atomic number is 20 and the mass number is 40. Give one similarity and one difference between the nuclei of potassium 40 and calcium 40. If you see here, the mass number is remain same, which is 40 on the left side and 40 on the right side. We need to add the masses on the right side. 40 plus 0 is 40, which is on the left side. On the other hand, we need to add up the atomic numbers, which is 20 and minus 1. When you add them together, we will get the 19, which is on the left side. So the similarity is they have same mass number, but they have different atomic numbers. Let's see the model answer. The similarity is they have same mass number, which we can see from the equation, which is 40 and 40, but they have different atomic numbers. Here the atomic number is 19 for potassium and for calcium it is 20. 2.3 is an AO1 question, and this question is from the topic of half-lives and radioactive decay. The activity of a sample of potassium 40 is measured 3 times. 3 different measurements are given here. Which of the following statements explain why the readings are different? So it is a radioactive decay, and radioactive decay is a random process. It is not a constant process. Therefore, we will say the radioactive decay is a random process. The reason behind it is that every time you can't predict that how many radiations will be emitted or what is the count rate per second. So the correct option is the radioactive decay is a random process. 2.4 is an AO2 question. Figure number 3 shows how the activity of a sample of potassium 40 changes over time. Figure number 3 is given here, in which the graph is given. The mass of the sample in milligrams is along y-axis, where the time in billions of years is along x-axis. We can see here the graph is gradually going down with the time. Use figure number 3 to determine the half-life of potassium 40. We will use the graph. The maximum value in the beginning is 1100 milligrams. Half-life means the time when half of the nuclei will left behind or half of the nuclei have been decayed. So the half of 1100 is 550. We will go on the graph. We will come here 550. From 550 we draw a straight line to our graph. Then we draw the straight line from the graph towards the x-axis. The approximate value is 1.3 billion years. 2.5 is an AO1 question. When food is eaten, some of the radiation the food emits is detected outside the body. What type of radiation would not be detectable outside the body? This question is from the radioactive decay and nuclear radiations. The student must know the properties of alpha, beta, and gamma radiations. So, among these, alpha is the radiation which has low penetrating power. Beta and gamma can be detected outside the body. The radiation which is not detectable outside the body, that is alpha radiation.